everyone, my name is Yojita. Today we are going to discuss about map operations on sequences, transforming elements. While going into our topic, let us first discuss about what is map. Now let us look into the brief explanation of transforming elements in map. Now let us discuss about map operations on sequences. Map operations on sequences generally refer to applying a transformation function to each element in a sequence, such as a list or array. This concept is common in functional programming and is often implemented using the map function. And also in Java, these operations are achieved through the Stream API, which includes various transformation and mapping functions for sequence. And in coming lecture, we will see a detailed breakdown of common map operations on sequences. Basic mapping with map. First, let us discuss about how map works. When you use map on a stream, it applies a function you define to every element in that stream. This function takes an element as input and produces an output, which could be of the same type or a different type. The result is a new stream that holds all the transformed elements. For example, you might use map to square each integer in a list, convert strings to uppercase, or transform data types. Like for example, you have a list of integers 1, 2, and 3. By using map to square each integer in a list, then the transformed elements would be 1, 4, and 9. Not only integers, you can also convert strings, like you can convert lowercase to uppercase by using map, and also from uppercase to lowercase by using map. Now let us discuss about key points about map. Transformation does not change the original elements in the stream. Instead, it creates a new stream with the transformed data. As you can see, this is the original data, that is 1, 2, 3. This is a list of original data, and this is the transformed data. After using map, after using map to square the integers in a list, you get this transformed data. And for each element in the input stream, there's exactly one transformed element in the output stream. As you can see in this, for 1, the output stream is 1, and for 2, the output stream is 4, and for 3, the output stream is 9. For 1, it only have one output stream. Like this is 1-to-1 mapping. The function you provide can transform elements into any type. For example, you could convert a list of integers into a list of strings, or a list of objects into a list of one of their properties. Not only from same data types, you can convert it into different data types, like strings to integers, integers to strings, vice versa. When to use map? When you want to use the map, you need to apply the same transformation to each item in a collection. And also, when you want to create a derived list of values, such as extracting specific property from each object in a list. And finally, map is powerful because it allows you to easily apply transformations in a single readable line, making your code concise and expressive. Now let us see and analyze the code by using map to convert list of integers to square integers. Now let us see the code step by step. First, the import java.util.arrays. This imports the arrays class. Next, they use java.util.list. This imports the list interface to create lists. Import java.util.stream.collectors. This imports the collector class, which provides methods to collect elements from streams. And next, this is the name of the class, map operations example. This is the main method, and this line is the list initialization. This creates a list of integers named numbers with the values 1, 2, 3, 4, and 5 using arrays as list. This list contains the numbers we want to work with. Now using map, list integer squared numbers is equal to numbers.stream. This converts the numbers list into a stream, which allows us to perform operations on each element in the list in a functional way. Now this map number to number into number. This applies the map function to each element in the stream. For each number in the list, the lambda expression number to number into number takes the number, squares it, and returns the squared value. The map function creates a new stream with these squared values. Next, collect collectors dot to list. This collects the elements in the transformed stream back into a list. The result in a new list of squared numbers stored in squared numbers. Now this system.out.println is used to printing the result. This line prints the squared numbers list to the console. It will display squared numbers 1, 4, 9, 16 and 25. Finally the code creates a list of numbers, squared each number in the list using the map function, collects the squared numbers into a new list and prints the result. This demonstrates how map can be used to transform each element in a list collection. Map operations in Java. In Java, the map interface primarily focuses on operations involving keys and value pairs, where each key is mapped to specific value. However, if you want to perform operations on sequences of elements, such as transforming or mapping values in lists, Java provides the Stream API, which includes a map function. This map function can apply a transformation function to each element of a sequence and collect the transformed elements. Now let us see some key operations related to mapping and transforming elements in Java. First one is transformation. Transforming each element in a sequence using map. In this operation, you can convert from uppercase to lowercase and vice versa, like from lowercase to uppercase. And then the second operation is mapping elements to different data types. In this, you can map a list of integers to strings and list of strings to integers. And third operation is mapping objects to specific fields. In this, map is commonly used to extract certain fields from complex objects. For example, if you have a list of person objects, you can extract only the names. Then the fourth operation is chaining multiple transformations. You can chain multiple transformations in a single stream operation. For instance, you could first convert names to uppercase and then extract only those names that start with a specific letter. Means first, if they are in all lowercase, you can convert them into uppercase, and also from these uppercase, you can extract the specific letter starting the name and you can extract that names. And the next operation using flattening nested collections using flat map. Sometimes each element in a collection contains another collection. Flat map is used to flatten these nested collections into a single sequence. Finally, map transforms each element by applying a function, example changing case, converting types, and filters elements based on a condition. And the last condition, the last operation, that is flat map. This flattens nested collections into a single stream. These operations provide flexible ways to work with sequences, helping you easily transform and extract data. In the transforming elements by using map, there are mainly 5 operations. We already seen the operation to convert the list of integers to square of the list of integers. Now let us see the list to convert the list of strings to uppercase. Let us see the code and analyze it step by step. As you know, first they will import the arrays and list and stream collectors. Next, this is the class name map transformation example. And next, it is the public static void main. This is the main method. And next, this line creates a list of strings called names and initializes it with the values Alice, Bob, and Charlie. Arrays as a list is used to create a list from an array of strings. The result is a list string containing three names in lowercase. This block of code conforms each name in the names list to uppercase and collects the results in a new list called uppercase names. This converts the names list into a stream, enabling us to perform operations on each element in a functional style. These string to uppercase, these applies the map function to each element in the stream. The map function here takes each string element and applies string to uppercase, converts the string to uppercase. For example, Alice becomes uppercase Alice. These collectors dot to list. These collects the elements in the transformed stream into a new list. The result in a list string containing the names in uppercase, which is stored in uppercased names. Next, system.out.println is used to print the output, and you see the expected output like all they become uppercase. This program creates a list of names in lowercase, converts each name to uppercase using map, collects the uppercase names into a new list and print the result. This example demonstrates how map can be used to apply a transformation to each element in a list. As we already discussed two operations, this is the third operation, extracting a specific field from objects. Now let us analyze the code step by step. As we all know, first they will import packages, arrays, list and stream collectors. Next, this defines a simple class name, person with two attributes, string name and int age. This is the constructor method that returns the name of the person. This method will be used later in the code to retrieve the name property of a person object. And next, it is a class definition, and this is the main method. And this list person people is equal to arrays dot as list. This line creates list of person named three people with three entries. Like we taken the three entries like Alice, Bob, and Charlie. And this code transforms each person object in the people list to just their name and stores these names in a new list called names. People.stream converts the people list into a stream, allowing operations on each element in a functional way. This line calls the getName method on each person object, extracting the name attribute. This results in a stream of names. These collectors.toList collects the elements in the stream back into a new list. The result is a list string containing only the names which is assigned to names. Next, this prints the output, and the whole program creates a list of person objects using map to extract just the names from each person, collects those names into a new list, and then prints the list of names. This is a good example of using map to transform a list of complex objects to a list of specific properties. This is the another important operation, flattening nested collections with flat map. Now let us see the code. As you all know, these are the packages that we import, arrays, list and stream collectors. This is the class name, map transformation example, and this is the main method. And next, list string. This line creates a list of lists named nested list. It contains three inner lists like arrays as list Alice, Bob, and arrays as list Charlie and David, and arrays as list Eve. This is the first inner list, and this is the second inner list, and this is the third inner list. And these line flattens nested list into a single list containing all the names. Nested list dot stream converts nested list into a stream, allowing operations on each inner list in a functional style. This dot flat map list stream, the flat map function is applied to each inner list in the stream, converts each inner list example Alice Bob into its own stream of elements. Flat map then flattens these streams into a single stream of elements. So instead of having a stream of lists, we now have a single stream containing all the individual streams like Alice, Bob, Charlie, David, and Eve. And this collectors.toList collects the elements in the flattened stream into a new list named flat list. The result is a list string with all the names in a single list. And this system.out.println gives the result, prints the result. And the summary, this program creates a list of lists containing names, uses flatmap to flatten it into a single list of names and prints the result. The flatmap function is crucial here for combining all inner lists into one continuous stream of elements. In summary, the transformation function in map is applied to each element individually. And also the transformation happens is within the map, and also result is a new collection where each element has been transformed according to the provided function. And also transformations using map or flat map allow for concise and readable data manipulation by applying operations on each element within the sequence, making it easy to apply consistent modifications across an entire collection.